set this experiment up. I previously started with an experiment with whole beans with coffee grounds on top, and those coffee grounds were spent coffee grounds. And the idea was to understand how particles move around larger objects with the flow of water. So I repeated this using Compresso, and this time I put only whole beans in first before I put spent coffee on the bottom, then whole beans, and then spent coffee on top. So this way, the water should go straight through. So if there's any finer particles making it all the way through, then I'll see them in the cup at the bottom. So here I'm putting in the fine grounds on top, and I pack them in with my finger a little bit to make sure it's like a firm pack. So in the first experiment, I didn't have any coffee grounds in the main basket of Compresso, and I had the shower screen on there. I originally started without the shower screen, but I decided to add it back in because I wanted to see, do particles make it from the main portion down, or do they get clogged when they hit a shower screen? And then you could see how much finer coffee grounds are in the basket below. So the basket below is on the left, so I put the puck screen on top, or the shower screen on top, and a couple coffee beans back in. And these coffee beans are just whole beans. They were a dark roast that they were too dark for me to drink, so I kept them for experimentation. So I put this back on top. And it was a little tricky to get it back on there, but then I just pushed everything down, and I'm ready to experiment. Everything's nice, and I had to push it down a little bit more. I don't know how much it matters that the surface being compact on top or flat, but it worked well enough. So I adjusted the camera view, and I started with cold water. Cold water didn't really work. You'll see it here. The cold water kind of stops flowing almost immediately because the spent grounds are mostly less than 400 microns in size. So I had sifted them for prior experiment, and 75% of them were below 400 microns. So this didn't quite work. So what I did is I poured out the water, and I replaced it with hot water. That worked a bit better. As you can see, a lot of the coffee floated at the top. And then I tapped it a few times before I started pushing water through. The intent here was to try to get a little water motion so I could see if I could improve the headspace, because I end up having to pour water in a few times during this experiment. So I start pushing down on the plunger here, and you see a channel form. And in this channel, you can see that coffee grounds are moving inside of this channel. They're being pushed through there. And this is not quite representative of what happens in the puck, because the puck is fully pressurized. So it's hard to know if this kind of situation occurs once the puck is full of water. However, this is pretty representative, or should be pretty representative, of what happens at the beginning of the shot. Whereas any crevices you have open, the water flows through faster. So I added a bit more water. And again, it goes down to the same area. And if you look at the bottom above the shower screen, it kind of fills up with coffee. And so I pushed a bit more, and the water goes straight through once it gets to there, but more coffee grounds are accumulating down at the shower screen. So I dumped it, I pulled out the plunger, and then I dump it out a few times into 4 different cups to try to see how much of the coffee grounds move to go all the way through the filter. So I believe it's in this one or the next one. Yeah, the whole thing fills up with water. All the air bubbles come out, and then everything kind of goes pushes down and collapses the column. So you have a compression of all the finer particles, and you can't see it in there, but there are some fines that are actually in the cup, or finer particles, I should say, because these aren't fines as we typically think of when we talk about the theory of fines migration, where you have particles that are less than 200 or 100 microns. These could be larger particles. I have yet to determine what comes all the way through, but I did collect samples at the end, so I'm going to be able to take a look. So I did one more run through water, but as you can see, you have coffee grounds through and through. You don't have this two different layers anymore. And then the bottom of the shower screen is completely filled up. Some of the beans actually float to the top, which is to be expected of whole beans. And it's partially why they float upwards. So it's quite possible that this phenomenon could happen with larger pieces of coffee, but I'm not sure how quickly it would happen in an espresso setting. Okay, so I'm gonna dump that into a cup, and then take a look at what else we have. So I'm gonna dump that to a cup, and then we're gonna take a look inside and see what we see. So I did one more run of water through here, so you can see from a higher level, and then I'll dump it out after this. So this was just to try to see if anything else is coming through in terms of particle movement. But again, most of these cups had a little bit of particles, but not a great amount, or not the amount I would expect. And then okay, so now I'm gonna take this puck and so now I'm going to take this puck out and see what's inside. So first we look in the bottom chamber. This is where usually coffee grounds go for compresso, and it's full of beans. There are almost no grounds in there. I took a look, and I took some photos. I have a photo in a minute that shows I don't see any grounds in there. And then I push the rest out, and it's just a clump of coffee and coffee beans mixed together. So they're all just mixed in there. It's completely collapsed. It doesn't look like there's many big openings anymore. Now we can look at each individual glass over light, so we can see that there's a little bit of particles left that are coming, that went all the way through. So that's the first bit. The second bit, this is split into 4 cups. So this is the third cup, there's a little bit, and the fourth cup, there's also a little bit. I didn't notice whether there was a big difference between the cups. They seem to be about the same. So here are the beans. There's very few particles in there. And this just to give you an idea of the hole size. So, because when we talk about fines going through the holes, we want to know how big those holes are. And so here's the coffee or the water, wastewater that I put onto a plate. And then I tilted the plate a little bit so I could separate the liquid from the particles, and I sucked out most of the liquid. And then I put this into a bowl, and so I can measure the particles distribution, and I could measure the weight.
So I then took these little bits and I looked at the particle distribution. The amount of coffee that came out was less than 0.01 grams. It didn't even register on my scale. So most of the particles are less than 350 microns in diameter, which would make sense considering that the hole size on the Compresso is around 350 microns on average. So looking at cumulative distribution, it tells a similar story. And I did one more experiment on this, I'll show in another video, because this turns out to be more interesting than I originally thought. So I decided to do the same experiment in a coffee machine.